Hydrolysis is the splitting of a large molecule into smaller molecules by the addition of water. Hydrolysis is the reverse of condensation. When water is added to an ester under alkaline or acidic conditions, the ester splits to produce the alcohol and the organic acid from which the ester was made. Hydrolysis under alkaline conditions results in the acid produced reacting with the alkali to form the salt of the acid. In the first equation, acidic hydrolysis, an acid and an alcohol are formed. But in the second equation, alkalinic hydrolysis, a salt of the acid, sodium propanoate, is formed and alcohol. Saponification is the process by which soap is made. Generally, saponification is the alkaline hydrolysis of a long-chain esters in fats and oils to form glycerol and the salts of the fatty acids, carboxylic acids. Fats and oils are formed from the reaction between propane 1,2,3-triol, a trialcohol known as glycerol, and naturally occurring long-chain organic acids called fatty acids. A single molecule of glycerol combines with 3 molecules of fatty acids by way of ester bonds to form a triglyceride. The alkaline hydrolysis of fats and oils produces glycerol and the salts of the fatty acids. The alkalis used are chiefly potassium and sodium hydroxides, hence soaps are sodium and potassium salts of fatty acids. Soapless detergents are generally the sodium and potassium salts of alkyl benzene sulfonic acid, a petroleum derivative. For example, sodium dudecyl benzene sulfonate is the active ingredient in many laundry detergents. The structure shows a sodium salt of an alkyl benzene sulfonate. The term detergent is generally used for any form of cleaning agent with lathering effects. Detergents are used in the removal of dirt or other foreign matter from contaminated surfaces. A common feature of detergents is that they are made up of relatively large molecules. One part of the molecule is soluble in organic substances and the other part is soluble in water. Detergents may be soapy or soapless, synthetic. Using only water is not good for cleaning because water has poor wetting properties and a high surface tension. Surface tension is the ability of the molecules below the surface of a liquid to exert an inward pull on the surface molecules of the liquid. It is this property of water which causes some substances to float around in water before they are dissolved or become wet immediately. Water and grease are immiscible because water is a polar substance while grease is not. When detergents are placed in water, the force that pulls the molecules of the water together is reduced, causing less tension on the surface of the water. When this happens, grease and dirt molecules are more able to spread throughout the body of the water. Detergents have 2 main parts, the head and the tail. The head. This part has polar characteristics and tends to attach itself to water. It is water-loving or hydrophilic. The tail. This part has nonpolar characteristics and tends to attach itself to dirt and grease. It's grease-loving or hydrophobic. The X in the formula represents any number of combination of CH2 in the formula that makes up the tail of the detergent. The tail of the detergent is a hydrocarbon combination which is nonpolar and unable to attach to water. It's hydrophobic, but is able to attach to grease and dirt. The head is slightly positive and negative at different atoms in the molecule. It's polar and is able to attach to water, hydrophilic, but not to grease and dirt. The tails of the detergent, which are grease-loving, move towards grease or dirt on fabric. They attach to the grease and form an emulsion. This emulsion is now able to be washed from the fabric due to the head of the detergent being water-loving. Grease and dirt are lifted from the fabric and carried away as an emulsion by the detergent.